Hey guys, and welcome to North Carolina. This video, as you may or may not see already, is high-speed rail. I say may not because a couple videos ago I changed the color scheme of what each color means. So it's not just blue, it's many different colors, like a big rainbow of colors rather. And as I go through the line, I'll explain to you what they mean. But let's get to the big picture first. North Carolina, especially what I'd like to call the urban crescent between Charlotte, Greensboro, and Raleigh, is growing exponentially fast. Many people are relocating here, not only from the Northeast but also from California to escape high house prices. So the suburbs of all these cities and also the city centers, but especially the suburbs, are growing at an astonishing rate. What comes with suburbs is people traveling long distances. In fact, many people do commute between many of the different communities along this line. So this line has many different stations along its route. It'll have ultra high speed and regional high speed. The ultra high speed will stop at Charlotte Airport and Charlotte Central, then direct to Greensboro and Raleigh. The regional high speed will obviously stop at all stations, and I think that is vital to truly capture the true potential of high-speed rail, as it serves smaller and more areas as well. This line has a displacement of 137 miles northeast and its distance is around 173 miles. So its distance to displacement ratio is actually relatively high. However, there's something to consider. If you went through a straight shot from Charlotte to Raleigh, you would skip a lot of communities. And believe it or not, there is a straight line that goes from Charlotte to Raleigh. That's where all the freight trains will go. The freight trains will be dedicated along a line going right here, pretty much parallel to Route 109 until Sanford and then going up to Raleigh. On the other hand, if freight needs to be moved from Charlotte to Greensboro, there's a line going up here and it'll go via Winston-Salem to Greensboro. So this line can be purposed for passenger trains. The top speed of this line is 300 kilometers per hour, but there are many other sections that run slower, and I'll get into why that is later. So without further ado, let's get, or rather touch down at the airport, and I'm going to try my best effect at this. So you're coming in, you're landing. Imagine that wearing a pilot, okay? I don't know if this will work that well, but okay, so your plane has just landed at Charlotte Douglas International Airport. I do admit Google Earth does not like doing the airport thing. When you try to land, it just tries to flatten the screen up vertical, but there's nothing I can do about it. So let's just say you landed at the airport, and from there you have an option. How do you get to Charlotte City Center? You could take the highway, and it's not that far, it's around 5 miles. But you could take the train within 3 minutes, and I extended the high-speed line here to connect the airport with Central Charlotte. Now that's not all. Believe it or not, this is the most busy airport in all of North Carolina. It's like the 7th busiest in the USA. It's actually American Airlines' second busiest hub after Dallas. So a lot of people will change through here, and a lot of the Southeast, along with Atlanta Airport, these two airports are where much of the interior Southeast relies on for their main gateways. So there has to be long distance high speed rail connecting to these airports, and Charlotte is one of them and no exception. The terminal rather, not the terminal either. The terminal is located just south of where the station is going to be, and it's right along the main road too. So yeah, that's pretty nice. You can essentially walk there, or shuttle buses can take you there. So the line will continue now. Now it'll go through here. Not much curve straightening needs to be done. It'll have a speed limit of 250 kilometers per hour, but in all honesty, Charlotte Central is right here. So I don't think 250 is even necessary. Maybe 200, 180. Like enough that you don't even need to upgrade the tracks. Just electrification, because believe it or not, adding concrete rail ties is necessary for higher than 200 kilometer per hour speeds. But since this is 5 miles, it won't make much of a difference. So the next station is Charlotte Central. Charlotte is the busiest and biggest city of North Carolina. It's home of the Carolina Panthers right here, as well as the second biggest financial hub under some metrics after Manhattan. Charlotte is also served by the Blue Line light rail, and this actually does not connect to where I plan the station to be. So what will have to be done, and I didn't draw this in my Webeo yet, is I do think a northwest southeast line, like a second line of mass transit, has to be constructed, whether it's BRT or another light rail line. It will also serve the more southeasterly reaches of Charlotte and more suburbs that the existing line does not serve already. Not to mention that there's no highway going directly northwest of the city, so some of these inner suburbs could definitely benefit from something like that. But that's a later Webeo. The focus on this is high-speed rail. After Charlotte Central, which is also an express high-speed stop, the line will continue. Now it will go to 250 kilometers per hour. Now here's some green. Green indicates new alignments. It's something I started back when I did my Canada high-speed rail video, but green is new alignments, and it includes curve straightening as well. Blue is all that needs to be done is concrete rail ties and adding catenaries or electrification. And here there's some curve straightening, but there's not much that actually has to be done. Now, just past this curve here, the existing line becomes one track, so I've designated a new color for that, yellow. Yellow shows that additional right-of-way may have to be used to make this a double track line. However, I don't think many properties at all would have to be demolished. At the most, maybe some relocating, as many times along this line there is a road right next to the line, so it may have to be slightly relocated, but nothing too much. Just before Newell, there's curve straightening here, and Newell is the next station. Newell is on the northeastern part of the Interstate 485 ring road, which is a new ring road that was just built within the last 10 years around Charlotte. It serves the vast northeastern reaches of the Charlotte metropolitan area. And as you can see, there are many highways that intersect here, not just Route 485 but Route 85 itself, which is actually what this high-speed railway line will parallel most of its length. It's really close to that, so people coming from the even further suburbs can come to Newell and take their train to whichever destination they want to go. Not to mention the northern Charlotte suburbs do not have to go south and take a train north. They could go here and go to Newell, which will only have regional high-speed trains serving, and this will take them to their final destination in a much more close-up fashion, if you know what I mean. You don't have to go to a city. It's like closer and more convenient. That's what I wanted to say. So Newell, the line goes on at 250 kilometers per hour, and if you're wondering why I'm doing 250 here and not 300, North Carolina is a hilly state and there are quite a bit of developments nearby. So rather than trying to build a straight shot or many straight segments with many tunnels and whatnot, I decided to slightly slower the speed but drastically lower the cost. That's actually a quote I borrowed from my very first Webeo from New York to Boston. And if you realize that, then this can actually be pretty effective. I'm going to go back to physics actually. I'm going to give some little physics thing. The equation for centripetal force is mvt squared over r, where vt squared is the square of the tangential velocity. So basically increasing the speed a little will drastically increase the amount of force required to turn the train, and it's all dependent on the friction and the static forces between the rails and the wheels that will allow the train to move, not to mention how much the passengers in the actual train will accelerate when the train is turning. Tilting trains should help somewhat because the normal force would be affected, but I think lowering the speed to 250 won't make that much of a speed difference even for the ultra high speed trains. Now if you have not been I've not really been paying attention to the colors, but I'll just go through this again. Blue is existing 2 tracks, so that nothing much has to be done, just electrification. Yellow is existing 1 track, so we have to upgrade it to 2 tracks and electrify. And green is new alignment, so everything's new. Now white here is also another new type of alignment. It's a tunnel. Trying to make this at a high speed through Landis actually would not be good, considering just past Landis is where the line is suitable to be upgraded to 300 kilometers per hour, and that's what I think this line should run at after Landis. So I think a tunnel here is vital. It's only 1.36 miles, so it's not that much. It's going to be expensive, but I think this will be a key part in enticing more people to use a line. China Grove's another tunnel. It'll have a length of 1.5 miles. The line will continue parallel to Interstate 85, currently on a one-track alignment, but it'll be upgraded to two tracks obviously for this line to be complete. Just past Airport Road here, the line will go back to two tracks, and that's Salisbury Airport, and the next station is Salisbury. Now Salisbury, the line here is already two tracks, but I made a viaduct over here to go over all the roads since all these are grade crossings. Some people may call them railway crossings, railroad crossings. I just call them grade crossings. But Salisbury is the next station. Now Salisbury is kind of its own area, but then again it minimizes the amount of traffic on the highway. It opens more spaces for trucks and people who want to go the shortest distances, and Salisbury serves as a good hub for like western central North Carolina. It's kind of in its own place in between Greensboro and Charlotte. So that's why I think a stop there should be necessary. After Salisbury, the line will go on. Now some new alignments will have to be built for curve straightening just southeast of Spencer, and just past that there is a big expense. It's probably one of the most expensive parts of the entire line. So this is part, I'm going to give you a bigger picture here. This here is one of the northwestern branches of the High Rock Lake. A new bridge was recently constructed on Interstate 85 to bridge this lake. Before, this was a big bottleneck for the road traffic. Well, the current railway line, it's a big bottleneck for rail traffic also. And not to mention, trying to curve straighten this would not be possible since it's a bridge. The maximum speed you could run this at is 150 kilometers per hour, which is half the speed of what this line is. And by the way, if you want a conversion factor, they're about, actually exactly almost, 0.625 miles in a kilometer. So 0.625 miles per hour is 1 kilometer per hour. Now if you don't remember that well, just estimate it to 5/8 or 6/10. 5/8 is closer to 0.625. So yeah, use that if you're not sure, but railway lines generally run in kilometers per hour, especially high-speed rail. That's why I'm going with it. So there'll have to be a bridge over the lake here, and then a brand new segment here. This entire thing will be almost 5 miles long or 8 kilometers long. But at Linwood, the line will rejoin the existing line and will continue along its journey. So yellow is existing one track, green is curve straightening needs to be done. A small tunnel here. I honestly don't know if a tunnel has to be constructed here, but I placed a tunnel there which would be 0.5 miles long, so yeah, and that would maintain its full speed. So this station is Lexington. Now I'm going to get into the station layout and then why a station is here. So this here, the blue and yellow, that would be where the regional high-speed trains will go. The ultra high-speed trains will go through a tunnel below Lexington station and emerge to the east of the town on a new alignment and eventually rejoin the existing tracks, which would be for the regional high-speed train. Now why am I building a station here? Well, one, it's a bigger area and it serves quite a bit of region beyond Lexington. Like all of this, are quite a few people that live here. Also, if you're coming from like Thomasville, for example, you don't have to go further northeast. If you want to go to Charlotte, you could just take a quick ride down to Lexington. However, this actually serves Winston-Salem. And Winston-Salem, I didn't make the line go up there because the existing lines are really not suited for high-speed rail. Not to mention that this is much of a high-speed corridor anyways, and trying to bypass this would add a lot of travel time between the main Crescent line, if you will. So this is a station for people in Winston-Salem wanting to go southbound or westbound. So after Lexington, the trains roll on. Mix of curve straightening, new alignments, and widening the rails to 2 tracks. Thomasville, there's a viaduct, but after Thomasville, we're back to blue. Blue is good. We already have 2 tracks here, just concrete ties and electrification. Next station is High Point. High Point is also a regional high-speed stop. Express high speed will go through at 300 kilometers per hour. High Point has a decent population, and it's actually along the western periphery of the Greensboro metropolitan area. So everywhere from even southwestern Greensboro all the way to just past High Point will be served pretty well by High Point Station. And it's also quickly accessible via Interstates 85 and 74, so it's not too hard to get to either. And by the way, I do think all these stations should have some type of park and ride system. This may cause some buildings to be destroyed, but if it's underground or like tall so that it doesn't take much space, it'll be okay, because park and ride is really the only way to go in a place like North Carolina. If you're trying to build this in New York City, where like 30 railway lines come to each station, then yeah, you don't need park and ride. But here, this is like the only line, so park and ride is vital. Another tunnel here, this one is of length 0.92 miles. Curve straightening just after that. Jamestown has a short segment that doesn't need to be changed besides the electrification. And then here again a short curve straightening segment. And I believe after this, there's not much that has to be done. Maybe curve straightening here. I put it as curve straightening, but I don't even know if that has to be done, because you're already really close to Greensboro. Greensboro is one of the larger cities of North Carolina. I believe it's a third largest. I believe Raleigh's bigger, but if I'm wrong, you could tell me that. But Greensboro is a big burgeoning manufacturing hub. Many manufacturing jobs, especially in the automobile industry and trucking industry especially, are relocating from the northeast to Greensboro because of its lower cost of living. So it's going pretty fast, and this will be an ultra high speed stop. And yeah, it'll also serve Winston-Salem and the western reaches of the Greensboro metropolitan area. So it's where these people can get on. Yes, I know it's kind of like a downtown area. Winston-Salem, if they want to go east, they could either use High Point or Greensboro. Either one would work, but Greensboro has ultra high speed, so if they want to get to Raleigh as quick as possible, I would choose Greensboro. After Greensboro, the existing line becomes 1 track, so we'll have to upgrade it to 2 tracks. The line speed will decrease to 250 kilometers per hour because it becomes much more curvy, and it also goes through much more hills, so curve straightening is not nearly as easy. So yeah, nothing much. I think I explained what most colors mean. So yeah, so a new alignment has to be built through Gibsonville, and this is Elon, home of Elon University. Now at Elon, the line will have to slow down to 230 kilometers per hour to go around like this. I didn't think one curve would be like this. Curve wasn't as bad as some other ones, so I decided to decrease the speed to 230 using tilting trains. Oh yeah, and by the way, tilting trains are the best, especially for lines that are upgraded to high-speed rail. Now, new lines are not as useful, but if you want to upgrade a 100-year-old line to high-speed rail, tilting trains are the only way to go, because you could use smaller radii and keep the relative centripetal force on the passenger less. So it continues, and just past this curve, the line will go back to a speed of 250 kilometers per hour starting at Burlington. But let's stop at Burlington for a little bit. Burlington is a bigger place, population of around 35,000 people, near Elon University as well. So university students, remember, many don't have cars, many do have internships in bigger cities. So it's like a win-win for them. They could just go take a bus or something to Burlington, and then take the train from Burlington to any of the major cities in North Carolina. So just past Burlington, and all trains will use this, by the way, there's a small tunnel which is around 0.58 miles. And then now the existing line rather, becomes 2 tracks, so all that needs to be done is electrification and curve straightening. Some major curve straightening here, but there are no big hills, so I think this can be done. Maybe a couple of viaducts here just south of the Quaker Reservoir, but nothing too much. Now it's still parallel to Route 40 and 85. Now here is where it gets really interesting. And to do that, I'm going to show you a new perspective. I think this Webeo is first time I'm showing you a new perspective of Google Earth. So look at the existing line and look at the mountains to its south here. So the existing line, this is actually pretty hilly. If you go down, you could see that's a reasonably hilly area. So you could see why the existing line has to do that. So my first intention was build it more parallel to the contingency of 40 and 85. So kind of like this. But there are a lot of hills and a lot of tunnels would have to be built, not to mention viaducts. And this area here is also a scenic preserve. So I didn't want to go through that. So the only option I found was to make a more northerly alignment. This is still at 250 kilometers per hour, by the way, and then a tunnel of 1.14 miles in length through West Hillsboro. However, just past West Hillsboro, the line will come back to the existing line, but the speed will drop to 230 kilometers per hour, which is around 135 miles per hour. So yeah, because there are a lot of hills here, and just lowering the speed a little bit won't make much of a difference. There's a point where you have to say enough is enough, you have to build tunnels, but 230 is not at that point yet. So yeah, and the line will continue at a speed of 230 kilometers per hour all the way through Durham. There's a 1.14 mile long tunnel here, but nothing too big compared to some of my other projects. So Durham is a bigger place. It's growing quickly, home of many universities including Duke University, and around 10 miles to the southwest the University of North Carolina. Both universities, especially Duke, are relatively easily accessible from Durham. So that's why I think a stop should be here, not to mention it's a bigger city, so ultra high speed will stop here too. After Durham, the line will continue along its way. Now this is back at 250 kilometers per hour, and this is all double track now. I don't have any stations between Durham and Raleigh, but I don't think it's necessary. That could be more suited for like an urban line, but I may add one later. But as of now, this is just straight to Raleigh without any stations. So this right here is a new alignment at 250 kilometers per hour. This is a perfect example of why not necessarily increasing the speed to the maximum is the best idea. First, the train may not even be able to reach 300 right away, and second of all, if you made 300, it can't go through even this curve here, which very efficiently goes through, minimally disturbing the landscape. If you went through here directly, you would have to build a tunnel and or destroy many properties. So obviously the slightly slower speed, but much lower cost is preferred. Now the line becomes one track here, some curve straightening just south of Route 540, nothing too much. Here there are a couple tunnels, but not much like regular curve straightening. This tunnel is relatively long, it's 1.43 miles, because this here cannot be curve straightened, and this is like in the middle segment between two of the bigger places, so a tunnel has to be built. Tunnel is also here just south of Cary, because again this is like a downtown area, so yeah. Oh yeah, and by the way, like when I decide tunnels versus curve straightening, all of that, you have to look at the acceleration of the train as well. The train doesn't suddenly start at 300 kilometers per hour, whatever speed it may go at. It may be slightly slower. So yeah. So line will continue to actually go through NC State and ends at Raleigh. Raleigh is a capital of North Carolina, second largest city, growing quickly, and it's a very important hub for eastern-ish rather, South North Carolina. And that's the end of the line, because that's basically the end of the urban belt, just the eastern suburbs of Raleigh, and that's it. Now you may be wondering, there are some other lines here already. Why don't I serve them with urban rail. The high-speed rail line has to be built first. I'll give you a perfect example. In the UK, I'm going to the UK now because most of my recent videos have been in North America, but in the UK, in Slough Station, it's spelled Slough actually, and believe it or not, the trains actually go through there really fast at 200 kilometers per hour, but it's called Slough, and there is a branch line connecting to Windsor and Windsor Castle. If you have been to London for tourism, you probably know what I'm talking about. You have to take the train, switch at a station, go south. Do you think that branch line would operate well without the main line? Absolutely not. The main line is what runs a branch line. Not to mention both are run by First Great Western. Speaking of that, First Great Western, this line should also be privatized. I think private lines are the future. Many countries are switching to privatization of these services. Not just rail but transportation as well. I'll go to New Jersey, which is actually in the United States, but yeah. Their turnpike and Garden State Parkway are run through by private company, they user improvement projects fully on just toll generated. So it's not much governmental interference rather for those lines. So not lines, roads. So this line here, if it can be done through private contractors, I think that would be the best way to go. Now obviously it's a really long line for one company to run, so government aid may need to be infused for the start, but besides that I think that's how the line should go. So Charlotte Central to Raleigh, it'll take around 1 hour and 30 minutes. That's pretty fast, right, compared to the 3 hours it takes now. So it's around double the speed with a stop in Greensboro. That's on the ultra high speed. If you do the full thing regional high speed, it'll take maybe 2 hours, 2 hours 15 minutes. So it'll still be faster than just driving. So that's about it for this Webeo. I hope you enjoyed the train line through the hills and caverns of North Carolina. And thank you and goodbye.